mobile and web. So I'm going to focus specifically on Apple Vision Pro, but I will also touch on more platforms. So my name is Oskar, and I'm a React Native developer at ColdStack. I'm currently working in the R&D team on React Native Vision OS. I'm also a React Native core contributor and an open source maintainer. So let's start with a question. Who's heard of universal apps before? Raise your hand. OK. So first, let's define what universal apps really are. So the definition is apps that work across multiple devices and platforms. And yes, users have lots of devices. So we've got TVs, desktops, tablets, phones, smartwatches, XR headsets, and some of us even have smart fridges, which I didn't see anyone run React Native on, but I think this is just a matter of time. So here are a few benefits of universal apps. We can provide a familiar experience across devices. Developers can maintain a single code base, making development more efficient, and we can reach a broader audience thanks to targeting multiple platforms. So here is an example of a seamless experience across devices. So let's say you are doing a home renovation. You start writing a note about it on your phone, but after a while, you want to continue working on the big screen. So on your Mac, you just reach to your dock and click on the Notes app. And you get a seamless experience now on your Mac. So after getting some work done, you leave your office and go grab a lunch. While commuting, you take your tablet and start wondering about the home renovation there in the same app. After getting a lunch, you come back to the office. You find your XR goggles and you put them on. You search for the very same Notes app, which provides same familiar experience from other platforms, but now you can visualize your furniture in 3D while also taking some notes. So how can React Native help us in this case? Thanks to the wonderful community, we got a bunch of open source projects called out-of-tree platforms, which allow React Native to extend its capabilities beyond being only mobile focused. So here's a list of them. But how about Expo? As you probably already know, Expo is the official recommended solution for you to use. And on their website, they officially support Android, iOS, and web. But in reality, they also support tvOS and macOS. So the Expo team is working hard on adding out-of-tree platform support into their framework, which is awesome. But in order to leverage the full power of out-of-tree platforms, you still need to use the community CLI, because Windows or Vision OS are not supported yet. So now let's focus a bit on React Native Vision OS, the project I've been working on for the past months. So here is a list of the platform-specific APIs we introduced to make it easier to leverage the full power of Vision OS. Starting off with eye tracking. Apple doesn't expose information where the user is looking because this is a potential privacy threat. But we can opt into applying a hover effect whenever a user looks at an element. And this feature has been introduced to React Native by the cursor pointer style. Next, we introduced the Ornaments API so that users can attach ornaments to their windows. On top of that, we also added a default ornament that you can see on the screen, which shows a dev menu shortcut when running in dev mode. This makes working with the headset a little bit easier. We also introduced the Window Manager API that you can use to spawn and manage additional windows, and also pass and update data from your main window to the newly created one. XR API allows you to blend your content with real surrounding. It opens a new immersive space, which is a canvas that you can render into. React Native Vision OS uses SwiftUI lifecycle. The app entry point is now app.swift instead of the default main.m, which was Objective-C. And this change allows us to leverage the full capabilities of the Vision OS SDK. We implemented a set of reusable utilities that out-of-tree platforms can use to implement their own CLI commands. Thanks to this, you can now run React Native run Vision OS. So let's check out some cool examples of VR and XR apps that are already used in production to give you an idea of what you can implement in your apps. First, we've got Zillow Immerse. And Zillow is a real estate marketplace. They released an app that allows you to preview homes in 3D. They also use an AI-generated floor plans to help you guide you through the apartment. they combine the immersive experience with windowed UI to showcase more information. And I think this is a really cool use case of the Apple Vision Pro. Next, a really exciting app is Lowe's Style Studio, which allows you to preview your future kitchen in immersive mode. You can change every piece of the kitchen, like floors, walls, and furniture. And I think this really nicely ties to the idea of progressive enhancement. And here's the definition, but TLDR, this means that we can provide a basic content for all users, but offer advanced feature to those with most modern browsers capable of running them. So here is an example usage of the View Transitions API on Safari. So when you launch the app on Safari, you can see just normal transitions between views. And this is a baseline of what users expect. But if you launch the app on a supported web browser, you can see the transitions between views are now animated. And this progressively enhances the experience for the user of supported browsers. So we can apply the same principle to mobile apps that run across different platforms. So in this case, we have an app that runs React Native. We can move to the details screen where you can see the image of the item. But when we launch the app on visionOS, we can enhance the experience on this platform by presenting a 3D model of the item instead of just showing an image. And thank you. And all of this is implemented in React Native visionOS. And I know what you might think. Everything that I showed is cool, but we don't have months to dedicate the time of our developers to work on this. And I totally get that. So in order to check how long would it actually take to migrate a fairly big project, I decided to get to work. And the project that I chose is Expensify, which is an open source application that allows you to scan receipts, track expenses, and in general is an all-in-one financial business platform. So here's a quick look at the stats. It has almost 300K of lines in the SRC folder, over 120K of commits, and it supports iOS, Android, and web using React Native and macOS through Electron. And in my opinion, this is a pretty big project that will give us a comparable baseline to some other projects you might be working on. But before we jump in, I want to make it clear that all the steps required to add visionOS into an existing project are described in our documentation, so I highly encourage you to check it out. All right, so let's get to coding. First, let's take a look at the file structure. In our app roots folder, we integrate visionOS by adding an additional native project in the visionOS directory, right next to Android and iOS folders. And the first step is to generate a new project with the same name as the project you are integrating visionOS into. In our case, it was new Expensify. Then we can copy the visionOS folder into the root of our app. And this is a bunch of manual work that we are planning to remove in the future, thanks to a PR by Szymon Rybczak, which will allow you to run React Native at platform, followed by the platform name, and get the same steps completed for you automatically. Next, we install the dependencies. We've got just two of them. One is the main package, and the second one ships Metro resolver that rewrites the imports from React Native to React Native visionOS. Here, we just drop in the custom resolver into our Metro config, and everything should work smoothly. Next, we successfully install CocoaPods and try to build the app. And Xcode is building the app, but after a while, unfortunately, we get build issues. And this is because some of the dependencies that are unsupported on this platform are still referenced by CodeGen for the new architecture builds. So we shipped a fix for this. Dependencies that are unsupported for a given platform will be now taken into account by CodeGen, and it won't try to reference them. But obviously, some libraries are key to making your app work as expected. So let's take a quick look at the package.json to see what we are up against. And yeah, this app has lots of dependencies, so I didn't choose the easiest project to migrate, and this classic meme didn't come from nowhere. So as you can see, React Native heavily depends on the community to augment core with features. So bringing new platform required us to migrate key libraries to visionOS. Thankfully, most of the libraries got migrated by awesome community members, so thank you for that. Woo. But on the other side, there are still many libraries that are unsupported, and this is a real issue among out-of-tree platforms. What's worse is that there are multiple open pull requests adding VisionOS support that are not merged because some of the libraries are just not actively maintained. And on top of that, we can't patch everything. The Expensify app relies on Firebase, and when I tried to make Firebase work, I looked into the postspec of this library, only to find out that it relies on the native version of the library, which doesn't support VisionOS yet. So we had to comment out pieces of the codebase temporarily, but this can be fixed. So in order to make my job a little easier, I wrote up a small bash script that goes through the node modules folder and check if each library supports VisionOS. And thanks to this, I got my list. It had 43 dependencies, which is a bit shorter than the dependency list in the package.json, because some of the libraries are already migrated, and some of them are JavaScript only. Another thing that we needed to do is to disable some features of the mobile app. Let's take invoice scanning as an example. So for iOS and Android, we can just access the camera without any issues. But on VisionOS, at this point, it's not possible to just scan something using the built-in cameras. It's coming in VisionOS 2.0, but that's still in beta, so we had to disable this feature. After fixing all of the build issues, I got the Expensify app running on VisionOS. And as a next step, we could make the background more transparent and maybe add some VisionOS-specific features. So let's see a quick demo of the app running on device. So here, I'm trying to log into the app, and after a while, you can see a familiar user experience that you may already know from all of the other platforms. You can navigate, chat, and send money. So let's implement some VisionOS-specific feature to leverage the progressive enhancement concept for this platform. So instead of using bottom navigation, let's move it to the ornament. We can implement it in SwiftUI or create a new root view and embed it in the ornament. And here it is, the app running with the new bottom bar that feels right at home for the VisionOS platform. And while working on migrating your app to VisionOS, remember to take into account the human interface guidelines from Apple. It's a set of rules that will make your app a lot better on this platform. So, lessons learned. Overall, it took 1.5 days to get the app to the working state. It still requires more work, like adding a few missing dependencies here and there and fixing some commented code. But one of the biggest blockers are definitely dependencies. Thankfully, most of them can be quickly tested using patch package. And I would say this experiment went pretty well. The app works, and it didn't take months, as anticipated before. So here is how the timeline looks like. As you can see, most of the time was spent on getting the app to build and fixing the dependencies. But in the future, this process will get faster, as more and more dependencies and build tools will support VisionOS. And there's one thing I didn't include in this timeline, which is contributing the code back to the libraries. This was a really important step to avoid the nightmare of maintaining a fork or a patch. And this can really impact your upgrading experience and slow down your development, so upstream your patches if possible. Going back to the VisionOS project, building things in the open is great, and the community got really involved in this project. Starting off with the community recognition. Over the past months of working on this project, we've managed to get over 850 stars, and I'm hoping to get to 1K after this talk. You can scan the QR code. So, for the past months, we've been also traveling the world with Apple Vision Pro and showcasing React Native running on VisionOS. And the reception was great. We got lots of wow moments and questions about the framework. So, if you want to try it, I highly encourage you to visit CallStack booth and check it out. And this is a good time to mention that during this effort, we've been focused on giving back to the community. We did that by contributing more web-compliant APIs to React Native, better iPad, macOS, and tvOS support, easier brown fee integration for native iOS apps, and more. Last but not least, I wanted to thank Microsoft for helping us with this effort and also for bringing support to React Native Test App, which makes library development a lot easier. And we've been migrating most of our libraries to use Test App nowadays, so give it a try. Now, let's talk about the future of React Native VisionOS. So currently, React Native VisionOS is a fork of the upstream repository, and our ultimate goal is to make it disappear. We want to find a way to make it more integrated into React Native core and extract everything we've implemented into a smaller set of packages. So for example, Window Manager API could be also used on tablets and desktops. XR API could be leveraged on other headsets like the MetaQuest. And SwiftUI Entry Point will make us prepared for the future on Apple platforms. We are also working on bringing Babylon React Native support, and we've implemented the windowed rendering mode and are currently working on the XR mode. So recently, a new and exciting project dropped from William Candelon. It allows you to access the WebGPU API in your React Native apps, which is a great achievement. And we've managed to run it on VisionOS. And this can really enhance the experience of working with React Native and the XR platforms and lead to potentially unlocking the WebXR API for React Native. So you can start building for VisionOS today, play with it, and hopefully contribute some bug reports and fixes. I also want to thank Michał Pierzchała for giving me a chance to work on this and supporting the project along the way, and also Matt Hargett, who is our technical guidance and poked us with the idea of bringing React Native to VisionOS.